Same. Okay, so please you can open your R, right? What you have installed, and we are using the RStudio. So what is R? In simple terms, R is a statistical package. What do we mean by that? It's a package for, it started as a package for solving statistical problems. But with time, it developed, what it started as, what do we call it? X, a programming language called X. Okay, but this X was, it was paid for, right? You need to buy it. Okay, and it was expensive. So there were two professors at, I think, University of Auckland. Then they started with a free version of this so that people will have access to it free of charge. So the statistics community bought into this, and it became like a club, right? So if I am able to write something and make it available, and then another person can use it, and people started improving it. So now it's a community. If we type, because we cannot, so just type RCRAN Google. So if you type RCRAN, so this is it, the CRAN or the R project. Okay, so it's like this. So it's a comprehensive word, R archive network. It has become a network, but now it spans across all fields. All fields. So if you look at it, we have mirrors. The mirrors are basically countries. For the European and the Americans, they are way ahead. And so if you click on the mirrors, you have so many of them. And so what is new? The news and so on. There's even a journal for it, where if you write something in a package and so you publish it over there. And then the sources, the software, the binaries, the packages, and so forth. Manuals are also there. Frequently asked questions and then contributed. So this is the base of it. But it doesn't, this one is like, I say, if you want to buy a car, the basic one, they will load some of them with maybe alloy ring, oil, maybe the lights have designs and so forth. So that will cost more than the basic one. So R itself is not all that user friendly. So people, especially those that are not in the sciences, they were not using it. So people came out with the idea of developing an interface which makes it easier to implement. So there are several of them. So the one we are using is RStudio, but there is TinyR. There's also R Commander. So R Commander is just like a package like Minitab or SPSS that you can use, which is click, click, click. But what we are going to do, we have to program most of the time. So there are, it's more or less like a graphic user interface. Graphic user interface. So the example is RStudio, which is what I had you to download. But there is also TinyR. TinyR. There is also R Commander. This is quite easy to use because it's just drop down and so. There are others. I don't really keep track of them. Okay, so it's a community. So when you get especially this one, what made it popular is what we call packages. Now, I was using some few years ago, it was 5,000. Now look at it. So currently, the current package repository features 18,350 available packages. And it starts from archaeology right now to zero. So even though it started as a statistical tool, it has grown in such a way that because any role that you find yourself, there will be data analysis. So we ran some code for the video. Somebody was from the university. I was actually using it. So what happens is that these packages, they contain data sets. So maybe somebody will be here at Apis, will be doing some work, collect some more data set that you want people to have access to. You can write it in the form of a package. Then anybody at all, anywhere in the world can log on or download this data from the app, CRAN, okay, the network, and have access to it. So there are data sets and there are what we call functions. So functions are just like functions we do in mathematics, so it takes an input to give an output. So the functions are able to compute things. So for example, maybe we want to find the average, which is the mean, right? So in our will type mean, and then we pass in the data, it reports the mean. Maybe we want summary statistics for the minimum one, the maximum one, the median one, first quarter, second quarter, third quarter. We want the skewness, we want percussions, we want this, and that. We can get those summary statistics. We use functions to do that. So packages in now can be data sets alone, it can be functions alone, or it may be a combination of functions and data sets. Okay. So there are about 18,000. So if you have to load this together with your R, then you want to, some of them are quite big. The data sets will be twice. So for example, if somebody is working on the, let's say, biochemistry, say they have one bit, they do the sequences and so forth. That contains a lot of data. A lot of data. So if they do a package, it may be running in some gigs. If you want to upload, get all the 18, then your laptop cannot run that. So there are some basic ones that you need to run around, and then there are those that you install as and when you need it, depending on the install. So we'll go through all those as well. Whatever we do, it will be connected to this website. So the packages, if you go through it, if you scroll down, so tables of packages available. You see, so I think it's in, is it alphabetical or that? No, not in alphabetical. I think by the dates. Yeah, to date. So just, it's today is what, 10th? You see, people are still, so just today, how many? 1, 2, 3, 4, 5, 6, 7. There are 7 of them. So it keeps on growing each and every day. Okay. And so you can scroll, it goes on. So even this year, 7th, you see the number of packages, then you go to June. Yeah, so I'll come back to this later on. So now we go to our studio. So if you have logged on to your RStudio, you have an interface like this, isn't it? Okay, so I'll go through this. Okay, so your this thing looks like this, as I have over here. Now here, this side we call the script. Okay, so that is a script. So we call it our script. So, pardon me. Okay, was it? Or you can use this one. Okay, so that is the script. The script is just like the notepad. That's where you do all your notes. We write all our commands, what we want to do, and then we will run it. Once we run it, it means execute. Once we execute it, it will come to the console. Down. Okay, so the down one over here is what we call the console, as you can see. Okay, so we have script, we have the console. Okay, so you have the script, you have the console, then you have the environment. The environment will store all your data sets and functions. So when we store anything, that's where we now we can only assess what we have in our environment. So it's just like I always, you are in YouTube, somebody goes to the car and calling you. So now there will be mistakes that you commit or errors. One of them is when you want to call something, what you have not defined it. So I will not know what you are talking about. It will say it's not found. It's not found. So about anything we do, we store, we should show up at the environment. Next is history. So if you click over there, all the commands we will issue will be kept a copy, let's say a copy of it will be kept under history. So because I have been working, you see my history, but maybe you haven't worked, so you won't see anything there. But as we start issuing our commands, you realize that your own will also start filling up. Connections. Now there's tutorial. I haven't even looked at it, but I think that's also RStudio tutorial. So you can, check it later on to see what is it. I mean, just some few, I think a year ago, there was nothing like tutorial over there. So they keep updating it. If you look over here, you see R is what? 4.2.1. So you have to keep track of it and so forth. Then here, when we come down, we see files, right? Usually, R will start from your document. It will reside in your document, but we can change it. Okay, when we finish, you create a folder for the class, and then you store R in it so that whatever you do will be in R. It will be in that folder. and so forth. So files will show the files within the folder you are dealing with. Is that okay? And then plots. Plot is where all our graphical displays will be shown. Okay, so I think I have done enough for me to go back and illustrate some of the things so that you see. Okay, so first of all, let's try and say we want to demonstrate addition. So I say add. So I'm going to add 4 plus 5. Of course, this one we all know the answer. Now the question is, what is this? I wrote add, and then I wrote what? A less than with what? Dash, right? We call that assignment. So that is an assignment statement. So in now, once we do this, it means assign what is on the right-hand side, right, to the left. So it means L is assigned what is on the right. Okay, what it means is that if you do this as well, then the LHS will be assigned to what? The one on the right. But I hardly do this. Yeah, usually you find this. So this, we call this what? Assignment. Assignment statement. Yeah. So that's it. So we use that to always declare something or define an object. Okay. So there it is. So now let's click on the environment. You see there's nothing there, right? Or you see something there at the environment. Do you see anything there? Is it empty? Okay. So now let's run this. To run this, you click anywhere on the line. It can be at the beginning, in the middle, or somewhere, or at the end. Then you see this, that arrow. What does it say? Run the current line or selection. So we can, if you click on it, have you noticed what is happening? What do you see? So on the console, what do you see? It runs what you have over there. Okay, then look at the environment. You see, what happened was that we ran it, so it added 4 and 5. It is shown in the console that you ran this. And then the environment add is assigned the value of what? 4 plus 5, isn't it? So we see 9 over there. Is everybody okay? Okay, so now that I have that, I can now call add. If I run add, you see the results show on the console. Okay. Now I have not done subtraction, so let me try and say subtract and run it. What do you see? Error. Object subtract not found, because I don't have anything named subtract in the environment. So that's what I was talking about earlier. That we can only call things that we have in our environment or another thing or in a package. But I'm here to go to how we install packages and so forth. So once I do that, I'll add all right. So now let's define subtraction, or let's say we subtract 20 minus 12. This we all know what the answer will be, isn't it? So let's run it. What do you see on the environment? Subtract is 8, exactly. Okay. So sometimes we may be interested in, let me do division, and I'm going to division. So division, we assign maybe 100 divided by 25. Now, this one, if I run it, it will divide 100 by 25 and assign it to what? Division, right? Okay. But it won't display it. So if I want to display it at the same time, I'll put all of them in bracket. So this one, okay, and then I've done this. You see the hash. The hash means a comment. What do we mean by a comment in R? It means it's something that is going to be run, but it doesn't really, it's just signifying that this is what is happening. So it doesn't really run as a code that you get result of. So as soon as R sees hash, anything following it on that line is assumed to be a comment. Is that okay? All right. So I'm saying that I'm commenting on it, and I'll say assign, and display. So what does that mean? It will assign the division of 100 by 25 to division and then display it on the console. So you see it in the environment as well. The result will also show in the console. So let me run it and then you see the difference. So look at this and subtract. You see subtract, it did not show the results on the console. So once I do this, it is assigned, division is assigned the value. As well, it is what? Displayed on what? The console. So that's the difference. Okay. So this shows that we can do basic computations in R. Okay, so R can serve as a calculator. We can use it to do anything in terms of computation. So you cannot be holding or opening R and then you ask of a calculator. Because whatever you can use a calculator for, you can as well use R to compute it. Okay. So now at least we've done examples on the script, the console, we've seen environment. Now can you click on history and tell me what you see? The script. All the commands you issue are there. Those are the commands you wrote and actually ran them. If you don't run it, won't show in the history. All right. Now let's look at the plot. So the plot will display all our graphs. Is that okay? Yeah. Yes. It will store them alphabetically. Yeah. Okay. So plots are the graphics that you can use in R. So for example, we can get a bar graph, we can get a pie chart, we can get a box plot, we can get a scatter diagram, we can even fit a linear or any nonlinear curve to that particular graph. Okay, there are so many of them. So let's look. Basically, we will come to plotting and do it in more details. So now we just want to see how it works. So let's plot 1:10. Now, what this means in R, the days, you can, okay, so you can also highlight and run. If you highlight and run, it will only execute those that you have highlighted. So for example, what I've written is a plot 1 to 10. Okay, but I just want to show you what 1:10 means. So I highlighted only that, and I'm going to click on run. And what do you see on the console? It's a sequence 1, 2, 3 up to 10. So R gives us a very simple way of what? Of representing a sequence. So if I have 1 to 10,000, I don't need to sit and be writing 1, 2, I just write 1, then colon 10,000. So it means less than in steps of 1. I can also do it the reverse way. If I list 200 is to 1, it means I should start from 200, 199, 198, and so forth till I get to 1. Is that okay? I can start from anywhere. I can start with 200 to 100. Or it could be 180 to maybe 300. Okay. So let's look at what we are interested in, which is the plot. Okay. So there, you can collapse each of these quadrants with what you see over here. So this one means let it be what? Occupy the entire window. Okay. And then once it is true like this, if you click on it, it will divide it into what? Into 2. Okay. If I do this, it will also restore it. They restore that way, so it's the same thing. And if you do it like this. So this is plot. Remember that I issued the command here, right? I run it, and the results is shown at where? The plot section. So that is what I was talking about, that we will see our plot in what? The plotting area. Okay. Now, why did I say R? One of the strong points of R is with this graphic. Okay. So for example, I can, these are circles that I use, but I can add this and see how many the various plotting characters we have. So you can plot, the default one is that circular ones. You can use a triangle, you can use plus, you can use times, you can use a diamond, you can use that. There are so many of them. Yeah. You run it and it will appear. So run it. Just put the cursor on it and then run. That one, okay, so you run it. Okay, you change your, now run it. Run. Yeah, okay, so I'm supposed to tell you this. R is case sensitive. Okay, so your dot is capital P. You will know where it has to be small. So R is case sensitive. So all the functions, even though it is yeah, it's the same. Yeah. So if you mix any of them up, I don't even know. So now you can pull out that side. And then I added another thing, that PCA. That is plotting character. So sometimes you don't want to use this setting. You want other characters you can use. That's what I was saying, that you can even pick for, let's say, drums and use it to represent the plotting character or ants and so forth. Okay, so later on, when we do graphics, we may be selecting, maybe you want the seeds plotting character. We can also use colors. Yes. Oh yeah, I mean, how doesn't recognize that space? So it will just create that. So for example, I can space like this, right? Yeah, and run it, it will still run. So because the same thing, you won't see it, but if I add something else, so for example, if I want to see the colors in R, I also use col, C-O-L, and then I do 10. So I want to see the colors 1, 2, 3, up to 10. So you see now it has changed. So the first one is black, second is what? Red, green, and so forth. Okay, so you can leave space, nothing really will happen. Okay, so that's about it. That's how we can get plot in R, and it will appear at that console. Any question? As I said, we'll come back to this, we'll treat it in detail. Any question? Yes. Yes. Oh, you can do so. But as I said, we'll do this in detail. So I can even choose from the rainbow colors if I want. So instead of 1 to 10, I'd rather choose it from the rainbow. You see, rainbow is also, so I choose 10 colors from the rainbow. So this one, when we do it, everybody's one will be different because we are choosing the colors randomly. So mine is what? Red for the first one. Another one is not really red, I think yellow. The other one, yeah, you can't read it. I'm not good at colors. So let me just leave it for the ladies for our lady to start. Actually, there. So if you like write a rainbow like that, your own may be different because it is sampling the colors from it. So as I said, as a plot, you have absolute control, whatever you want to do, unless you don't know how to go about it. Here, yes, here, for example, we will close all those areas. This is what happens when you do a series of events, then you pick the graph sheet within the closing area, but the whole graph is like you can't write anywhere. So we have control over all those things. How to make all those areas. Yes. Somebody wanted to ask about it. It's case sensitive, yeah. Yeah. Very. So for example, plot is all small letters. If you do P, like B, capital P, and then it will tell you plot not found. And then you know that you any question. So can I move on? Next, I move on to packages. Remember we talked about packages, right? So click on packages and then tell me what you see. If you click on packages, what do you see? Yeah, so all what you have there are packages. But these are the default packages. They are the packages that comes with the installation of that. So the first one you see is what? Base. Okay, so let's move on. You have put as well. What again? Yeah. So if you go on to the D column, you see Datasets. So go there and click on Datasets. It's already ticked there. So when you take it, okay, this is what you are telling me. If we go down here, you see data set is ticked. Now, what happens is that just like I talked about environment, packages, there are so many. We've seen that there are 18,300. Some of the packages will come with the installation of it, but when you start it, remember in your Windows, if you have so many programs starting with Windows, your laptop will take some time for it to start. So usually you go to startup and then you go and take some of them off. As and when you need it, you click whatever, you start it. It's the same with that. So RStudio just load only the packages it needs. the basic one. Any other one that you need to upload it, or we say load it into your working environment. So by loading it in RStudio, you can just take it. Okay, so for example, if we want to, let's go to down. There is a package called mass. Have you seen? It's also ticked. Yours is not ticked, so yours will be like this. So just take it like that. Now, when you take it, look on the console. What do you see? Library. So here, you see, R is just code. So whatever any clicking that you are doing, it has its component in a programming form. So instead of taking, we could have also used library. Is that okay? All right. Okay, so for example, let me, the new one doesn't group them, but the old ones will group them into system library and then user library. But now it doesn't do it anymore. It puts everything together. So for example, I have certain packages that you don't have. So I'm sure this one you don't have. Do you have mstart? You don't have, yeah. So this is a package for what? Environmental statistics, including or US EPA guidance. EVA is a stream value analysis with goodness of fit. You don't have all those things, right? Because that's what I do. So I download them. Okay. I'll show you how you can download each of these later on. But I want a common one where we can. Do you have forecast? No. Okay. You have foreign. Okay. Okay. So now, instead of loading taking foreign, we can do so here and say, so I make a comment loading packages. Okay. So I can say library, and look, as soon as I start typing, RStudio will give me a clue as what I need for me to select. So I just select it. Don't worry yourself typing everything. You can make a mistake. So as soon as you start, it will give you a drop down. Then you search for it and click on it. So I click on it like this. It tells me library, right? Okay, what do I need? It's foreign, right? Okay, and then I start. That also comes. I just click on foreign, right? And then, but look on the right as well. So I have to run this. You see, as soon as I run it, what happened to foreign? It stays. Yeah, so it means whichever way you can do it. Now, why do you have to know all the tools? Well, you see, sometimes you may be doing some work that may take time, or that needs repetition. So you can't be sitting behind your computer and then repeating it every time. Okay, so sometimes you can set it up. The computer cannot go and take for you. Okay, when one needs to start and it needs to practice. So what you do is that you use a library. That one can be done straight away. So here, you see this, you can work on it for us your home if we give you we have a living index on it. So when you are doing your project, your team, and you need to do an estimation, so for example, what I do sometimes may take weeks to be running over and over and over again, calculating things, doing this and so forth. So I can't sit down and if I use my laptop, the battery will die. So I'm able to send it here, or what they have even better ones. They have a high performance computing, very big for doing those things. So when you have very lengthy program, you can send. So I just interface, I send it there, right? And then it works. The computer will work. Once it's finished, then it will send me a mail that it's done. Then I can log on to it remotely and copy my files, and then I start working from there. can't be taken. The thing is running maybe 1,000 times, 2,000 times. So you cannot run one day wait. No, life doesn't work out. So then you need a live command so that anytime they lose it. Some of the time they even conflict. So that's how we load the package. So then what about if you don't have the package, what do you do? You have to install. So let's try and install. So for tutorial science, we'll be using packages like Actual. So let's install Actual. And then we will also need live contingency. Live contingency. So let's try and load these two packages. In other words, install, and we can have access to them. So you click on install, and then you start typing Actual. As soon as you start typing Actual, you see the drop down, then you select install. So you click on install and the packages section. And the package is installed. So click on install. The package again, click on package. You see install. Install, yes. And then you start typing Actual. So take your time, base, as soon as so you need internet. So you can connect to digital money. Just connect the why is it not? Unexpected. No, okay, I get it. Okay, let's do it again. So sometimes it takes every night. So once you have it, so you can now do the understand. So now let's do continue. So it's that simple. So somebody has taken the time to do all this. For you, all you need to do is just install and then you go. I will show you the way that goes for even one function. It's a whole lot. So to get a package, it's not a challenge. Let's try and do like contingency. No, install it. You install the library. Okay. But is everyone okay? So now we know how to install, right? Remember, just like we do update our apps and so forth, the packages, they also get updates. So when they get updates at the CRAN page, it won't update automatically on your phone. So you will see the update over there. If you click on it, it will also say for updates of all the packages you have. As maybe you'll be using the 3 years time, 2 years time. You need to update the packages, and you can click on the update button. That will only update things that have been installed. If you have not, if you don't have WhatsApp or let's say Telegram on your phone, you cannot update it. It needs to be installed. So it's the same principle that we use to work. No, your own is 4.1. So it is the R that you have not updated. So the R, you have to go, you can't update it, you just have to download the big one. So the big R. So you go to download R, and then you download it. But 4.1 will also work. Something like is everybody okay? Your own is still, once it is done, we are now going to look at how to use this one. So first of all, let's go to mass. That is it. Mass. Let's go to mass. Mass is an inbuilt data package. So let's search for mass and click on it. That has functions and data sets. Remember, data sets is also a package. But that one, it contains only data sets, no functions. Mass is a combination. It has some data set as well as some functions. So let's click on it. We use that to explain what packages are. Okay. So I said mass, right? So you go, it is arranged alphabetically. So you see mass over here. So please take it first, or it was taken already. Okay. So let's click. Okay, what does it say? It says what? Support functions and data sets for variables and replace mass. Okay, so first thing what I want you to realize over there is what? Functions and what? Data sets. So as I said, this is a combination. Okay, but if you go up to data sets, it says what? Our data sets package. So you see there's no mention of functions. Okay, some of them too has only functions. Let me, yeah, class, functions for classification. Did you get it? So this one, it doesn't have any data at all. So those are the types of packages you can have. Either functions alone, data sets alone, or a combination of what? Functions and data sets. So let's go to our mass. There, okay. So if you click on it, it will list all the objects, functions, or data sets in mass from alphabetical order, from A right down to Z if it has. So if you look at it, AB is determination of nickel content. ACC depths is what? Accidental depths in what? US and so forth. Now, ACE2 is what? Australian AIDS survivor data. So these are all real data sets from books. Okay. The mass package is it's the combination of functions and from it's actually from the book Modern Applied Statistics by Terry Venables and Ripley. It's one of the standard tests in statistics. Okay, if you go down, and let me check if they put it here. Usually it's at the, no, unless we click on one of them. Okay, so let's look at the last one is what? WT loss, weight loss data from an obese patient. Okay, so when you click on it, the first thing you see is this. Okay, so weight, WT loss is weight loss, right? Okay. So, and then you see mass in what? Curly bracket. So that is a package. So what it tells you is that WT loss is in what? The mass package. Is that okay? Then there you get description of it. Is weight loss data from an obese patient. So this one is just one person. Okay. So the data frame gives the weight in kilograms of an obese patient at 52 time points over an 8-month period of weight rehabilitation program. So you have a patient, maybe there's a program, and then within the 8 months, you keep on measuring what? The weight. So that's what it is. So to get the data, I'll come back to all this data frame, what does it mean, and so forth. So if you look at the format of the data, it says it's a data frame. The data frame is just a rectangular data. It's just like a matrix. I'll take this, like I'll describe it in due time. So, but what it means is that it's just a rectangular data. So it has days and then weight. Each of them, the unit is given and so forth. So if we want to, now that mass has been loaded, we can look at weight loss. So as soon as I start typing, it shows, and then I select, right? Because we have take mass, its content is now available in our environment, even though it is not, it doesn't show explicit. Okay, so let's display this. So you run it, and there it is. So that is it. So day one, the person went. Number of days elapsed is 0 because it's the first day. The person's weight was what? 184.35 kilograms. Then day 4, it reduced by almost what? 2 kilos. Day 7, also almost 2 kilos, right? The next day, the day 7 again, I think they did it maybe morning and evening, and it has reduced by some grams, almost 5 points, maybe 500 and something grams, right? Okay, and then the 11, it keeps decreasing, 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 and so forth. So that's it. So now we have access to this data. We can even plot it to see how it looks like, right? You remember plot? Yeah, so we can plot it like that and see. So you see, this is how the person's weight looks like. So if you were asked to predict the person's weight in the next 500 days, what will you do? What will you do? If you are asked to predict what will happen in the next 250 days, you don't have that data. You can find a model, yes, and to estimate, yeah. So you extrapolate. And this one is like, it's more or less line, not quite, but it looks like an exponential decay, right? Something like that. But the danger with this is that because it is decreasing, then if I ask you to check 1,000 days, it may go to infinity. Do you get it? But in real life, that's not possible. A human being cannot have negative weight, except maybe when you are in space. Even that is weightless. You won't have any weight. So you can just go up because there's no gravity to do that. So you have to be extra careful when you are using models, especially to predict into the future. Okay, it is possible that this person is on the diet, but as time goes on, fatigue sets in. He or she starts eating junk foods and chocolate and other things, then it goes up again. But you are using your model, you don't know anything there, so you keep extrapolating down and it's going down. Meanwhile, the person has started eating and the weight has started increasing again. So this is one of the pitfalls of especially the regression type model. That you can only extrapolate at best to what you know. Okay. Is everybody okay? Is everybody okay? So that's how we can have access to what? Data in a package. Okay. So if we can get data in a package like that, then definitely we can use also a function, right? So let me see if we can get one function that we can use. Through hist. Through hist is plot what? A histogram. Okay, so let's look at it. How do you use this? Let me look at through hist weight loss. But remember, a histogram is for what? It's for only numeric values, and it can only be a vector. Okay, so I can choose the weight, right? And do a histogram for it. There. So these are all, I'm able to do this because what? I have loaded what? The package. I have loaded the max package. I won't have access to it. When you finish, we are going to untick and then we try to do what we have to do and see the error. So that the dollar sign will come to this. Just select. Don't type on your own. It's a go. So as you type, it gives you a clue. Then you select it. Then you type inside the market. The dates. Because the dates are one thing, you can plot it. I mean, date for the histogram for the date. The for the weight is different. Is everybody okay with it? You must select that one. So you all have your histogram. Yeah, so if you are to describe this histogram, how would you say? How to describe this? Let's skip it. Why do you say it's let's skip? Because the stillness is called the longer tree. Which means because that one, let me tell you, of course, the person will not understand. Positively skewed. What does that mean? It's the weight decreases. Uh-huh. A lot. But the frequency is decreasing. This one, what it means is that you can say that within the person's weight, okay, mostly was between 120 and what? 140, right? That range, he or she hovers around there for a longer time. Okay. And then the 200s was a small, you remember the person was 180 something. And then when they started, it was decreasing. So the weight did not stay within that range for a long time. But when it got to 120 to 140 to 120, it took quite a long time. Is that okay? Yes. No, the person was 180 and then it was decreasing rather. So when you are explaining things, of course, you know the background of the data. If you give me this without the preamble, like because we know the preamble, that's why I'm trying to explain it to relate to what we know. But other than that, I will say, well, the weight, if you give me this one, I say, oh, majority of them are less than 160 kg. I'm right because I don't know the preamble, but this is just one person that we are weighing. So the person's weight was around 180 something. Quickly, he moved to the next range. And he spent some time between 180 and 60. Then from 160 to 140, a bit more than the previous one. And then he spent majority of the time within that. And then it dropped between 100 and 120. That was also smaller in terms of time or the number of weights that was recorded within that. So that's how this can be done. Yeah, because we were talking about for days. So it doesn't keep long. So within the 180 to 200 bracket, did not take long at all. That's why the frequency is smaller. Okay. So we come back to, so now we have used data set. We've been able to display the data set weight loss and then also what? A function within the package was mass. So these are some of the things we will be doing in relation to packages. So when we go to the actuarial science one, we'll be using them in this way. Some will be functions, others will be what? Data sets that we want to use. Okay. So what packages now we know that and so forth. Okay. Now I said we'll do an exercise. Let's untake this. Now if you untake it, it is the same as well using detach. So if we want to unload a package from our working environment, we use detach. So detach is then the opposite of what? Library, right? Now let's try and plot our weight loss. What do you see? Object weight loss not found. Who can explain why we are getting this? Yeah, because this weight loss is in what? The mass package. The mass package is not in the environment. So as soon as you see this, it should prompt you that either if it is something you have to define, then you have not done so. And sometimes you may write something like over here. Remember we did this. Assuming I have done addition, let's say product, right? Multiplication. So product, and product is, let's say, 6 times 7. Okay, I write this, and then I now come, and then I want to, let's say, show product. Remember, I've written it, but I have not run it. Okay, so those are some of the things you can. So then you'll be wondering why, but I've written it and so forth. So as soon as you see not found, it means if it is in the package, you have not loaded the package. If it is you that have to run it, it means you have not run it. So now if I track back, okay, and then run this. Now if I go and run this package product, I'll get my result. So if you see this, it's common. But I think from today, once this is you get through this, you know what to do to correct it. Any question? Okay. Next is help. Now remember that when we went to the packages, we click on it, then we went to click on what? Through his. As soon as you click on it, it takes you to what? From the packages side to what? The help. So help gives us more explanation about either a data or a function. Okay. So this one, it tells us that through this is what? This is the math package. It is what? It plots what? A histogram. Description. Creates a histogram of the current graphics device. So that histogram will be plotted on what? The plot section. So, yes. Yes. Mass. Yes. Yes. Yeah, you can. So for you to use through his mass should be that. If you need another, so we'll go to data set. There are data sets in there. We can use through his to plot that one. But the source of the through his is math, so it must be loaded before we can have access to it. Okay. Now, so the help, in doing help, we remember that we can click the, and then that will send us there. However, if we need help, we can use question mark. So anything we want information on, we use question mark. You question mark it. So WT loss. You see, what does it say? No documentation for what? Weight loss in specified packages and libraries. you could try or double. Why am I getting this? Remember, weight loss is in package. So when I do the single question mark, it just says through the packages I have in my library. If that data set or function is in any of those packages, it will show me. If not, it won't. So let's try the suggestion. The weight loss, the double one is a much more deep passage. So that one, you see, it is taking time. That will go through all the packages I have within my R environment and check where it will find weight loss. So remember that it is in what? Mass. So you see it's showing over there. And then VCTRS package 2, it has something like that's so if I go back now and I take mass, okay, now then the first one will work. Yes. Then it means then you have to help. That's it. So now let's look at the weight loss now. Because I've loaded the package, it will give me straight away the help on it. But because we are not loaded it, that's why I was telling us that there's no documentation. We can look at another data set. It is called an erasure. It's also in the mass package. So you see, as soon as I start typing, it gives me a clue. Then I select it. So if we do this, you see, an erasure also in mass package. Data on so and so and so. So basically, that is an introduction to the RStudio environment. Okay. Now we are going to create a folder and then we'll save our work and then we can call it a night. Okay. So first of all, create a folder for your class. I have already done my own. So every year I just keep on changing, like creating a new folder so that I know what I'm doing. So you create your folder, either on desktop or maybe if you have OneDrive in your OneDrive or Dropbox or whatever. It's always important that you keep your important folders and have copies in either Dropbox or because especially when you are doing your thesis, you can work and then 1 week to submission, then your laptop crashes. So you get to store your work. But if you have it on either OneDrive or Dropbox, once the laptop is going, you can log on to the cloud and then get all your material. It's quite important that you do that. So create a folder, name it up to 602. A folder either on desktop or my documents or where you usually keep your folders. So do so. At least okay. Is everybody okay? Have you created your folder? So you can create one, and then when you finish, you take it and send it to your email so that you know that it's all right. So now, in R, remember I said there are scripts, right? So we can save the script. We can save the history, and then we can save the environment as well. So let's start first with the script. And they are all together. Okay. All right. Okay, so we go to File, okay, and then Save As. Then you have to navigate to, okay, before then, let's do this. Sorry. Let's rather do session. So whenever you are working, you see, let's say this is a class, this is an applied class, but if you are doing another, what are the courses you are doing this semester as well? Pensions, contingencies, and so forth. So the contingencies, assuming they have given you assignment where you need how to do it, you are not going to save it in up to 602. You rather save it in contingency. So sometimes you may be working in so many files. Like me, I work because I'm teaching at the undergraduate, I'm teaching over here and so forth. I'm working with the students, undergraduate, postgraduates, both master, PhD, and so forth. So you can't be saving everything. So I always create a folder. Every student will have a folder. Every course has its own folder. And because it's a course you are doing it over here, I create subfolders for it. Okay. So usually before I start working, if I'm working with up to 602, then I will set my working directory to that folder. Then everything that I want to save, it will first go to that, unless I don't want to save it, and then I navigate. So to do that, you go to set working directory. There are three things over there: to source location, to file location. I'll use this. Next week, I'll show you how to use the source file location. So choose working directory. So here, it opens your folder, and then you navigate to the folder that you have created. Is that okay? So mine, I have to take act, no, not 202. It's 606. I haven't created a folder for you yet. So act to 602. This is 2022. Okay. So 2020. So then I say open. Now, when you finish, look on your console. It will give you the file path. Everything over here. So mine C users Aminca OneDrive Act26. What it means is that anything that I want to store now, the first priority is that folder. Unless I don't want to save it, then I'll go and do something else. Okay. So now then we can go back and save this, right? So even saving it, you can also click on the diskette over here. If you use a diskette before, then you should know this. But if you are from the 2000, from the 2098, you won't know this. But this is a diskette. We used to slot it into it. So that's also saved. So, but other than that, you can go to File and then choose Save As. Okay. You see now, it goes straight into that folder. So it's important that you set your working there. Otherwise, you'll be navigating to find your folder all the time. Okay. So here, so what I'll name it Act 602 and the same 2022. That's how I do. So if I go to 2019, I can get all my class exercises I did, or the in-class test and so forth. So I save it. Okay. So now when you finish, go to the folder and check the folder you just created, and then you saved something in there. Go there and check. I'll check mine. You see what I have over there? It's what? The name I gave. But look at the type. It's what? Alpha. So alpha is a test. Now we are going to edit RStudio. When we save, it is going to save the history and also the environment. But before then, we'll save a plot so that we know how to save the plot as well. Before we edit, and then that will be the end. So let's go back to our plot. Remember, we had some plot. So for example, some of these things, after here, you must export this to your web. Then you can talk about it like we were describing it. So how do you do so? Well, first of all, you can copy, right? You can copy and then just paste. Sometimes you can save. I prefer to save so that I don't have to come to how to replot it anytime. If you just copy, as soon as you close out, that's gone. So the next time you have to rerun it to get, but I would rather save it. And then I can now pick it from wherever I want to. And so you can save as PDF or you can save as an image. Is that okay? Here, you can zoom. Okay, when you zoom, you can also save as or copy address and so forth. So it's up to you how you want to do it. Okay, but I usually will do it over here. Just export and then I click on image. Look at it, the directory, if we had not set our working directory, we had to set the directory here too. Other than that, you finish, this one goes to my document, this one is at the other side and so forth. Okay, so it's important that you set your working directory so that everything you want to save will give that folder the first priority. So we name it maybe histogram, right? Histogram. Oh, I think this thing is histogram like that. Now here, image format. There are so many formats that you can use. F is the best. But in order to deal with, you need an X viewer. What it is, it's able to keep the image, the resolution or whatever they call it. So you get it quite nicely in that than JPEG. So PNG too is quite good. So PNG is quite universal. So other PNG. But if you are doing your web, then who took that in the latest training? None of you. Okay, so later on, I think next semester we'll do. Is this semester? Yeah. So I think later part in the semester we'll do short courses that we run. So I'm not sure we'll be able to. That one is a weekend, right? We'll see. Maybe later part in the semester we'll do it. So you can register and be part of it. Now, if you are using, here when you are doing presentation, you don't use PowerPoint. You have to use a latex view, which gives you more flexibility in terms of formulas and also images. So if you are using that, you save it as an X, and then you call it within the latex. Your graphs are very nice. When you print it, you can see it quite clearly. But in the absence of that, we use PNG, which is also equally good, not as you have in apps. So we select its format and then we save it like that. So now if we go back to our folder, we see a histogram is there, right? Which is the name we gave it. So that's how we will save our images as well. And if we click on it, you find it there. Okay. Now what else? So now we have to save our working environment. So to save, you can save it over here, session, save workspace as. Then it will also give you the same thing. So like this, you see, everything will go to the same folder because we set our working directory. And you can give it a name that you want. But because we are closing, we can also just close it. And it will ask us, do we want to save it? We say yes, and then we save it. So that's what I'm going to do. There it is. It said, do you want to save the data? I said, yes, save. And it's closed. But when I go to my folder, I have you seen .r data? So that our data contains your environment, right? And then the history is that history part that you look at. Everything is saved in what the folder we created. So that will be our introduction to R. And I think within the week, I'll give you a video